A $50 backdoor just took down Russia's most secure tank factory. At exactly 2:47 a.m., Ukrainian cyber operators triggered a logic loop in the Kasuka-4 electronic warfare suite, protecting the Ural-Vaganzavod facility at Nizhny Tagil. Within seconds, Russian radar screens went dark, showing nothing but atmospheric noise while swarms of FPV drones crossed into the defense perimeter unopposed. The backdoor was hidden inside Iranian-made fire control modules that Russia had been installing for months. What happened next wiped out half of Russia's annual T-90M production capacity in a single night. Here's exactly how they did it. For months, Russian technicians had been installing what they thought were routine fire control modules into their most advanced air defense system. They had no idea each one carried a hidden flaw. Fire control modules serve as the processing brain for weapon systems. They take raw data from radar sensors and run the calculations needed to track targets and determine firing solutions. Without these modules, even the most sophisticated air defense system can't tell where to aim or when to shoot. After Western manufacturers cut ties with Russia in 2022, Moscow faced a serious problem. They couldn't source the advanced components needed for their defense systems through normal channels. Sanctions blocked access to critical electronics from Europe and the United States. Russia turned to Iran to fill the gap. Iranian suppliers began providing fire control modules and thermal optics that Russian manufacturers could no longer produce domestically or import from the West. The Iranian fire control module measured roughly the size of a smartphone. The compact circuit board processed targeting data flowing in from radar systems, running the algorithms that turned sensor readings into actionable firing coordinates. These modules were designed to integrate directly into the Kasuka-4 electronic warfare suite, protecting high-value facilities like Ural-Vaganzavod. When you can't manufacture everything yourself, you have to trust your suppliers. That trust creates vulnerabilities. Modern warfare depends on complex supply chains that span multiple countries and dozens of manufacturers. Every component represents a potential weak point if it comes from an unreliable source or gets compromised during production. Ukrainian intelligence spent 6 months tracking the Iranian supply route. They intercepted communications between Iranian manufacturers and Russian procurement officers. They obtained shipping manifests showing exactly which components were moving through which ports and when they would arrive at Russian facilities. The intelligence work pinpointed not just the origin of the modules, but their specific destination within Russia's defense infrastructure. The backdoor consisted of a few lines of code embedded in the module's firmware. Once triggered remotely, it would generate false sensor readings that the Kasuka-4 system would process as legitimate data. Development and installation of this backdoor during manufacturing cost approximately $50. Iranian engineers pushed the compromised firmware through a single update cycle targeting modules destined for Russia. The modules integrated directly into the Kasuka-4 system's core processing units. That placement gave the backdoor access to the entire defense network. Ukrainian operators had identified the vulnerability and confirmed the modules were installed across Russian air defenses protecting critical facilities. At 2:47 a.m. on the night of the strike, a Ukrainian cyber operator in a secure bunker 800 kilometers away pressed a single key on his laptop. Within 8 seconds, the Kasuka-4 system protecting Ural-Vaganzavod began to fail. The Kasuka-4 electronic warfare suite represented Russia's most advanced integrated air defense system. Engineers designed it specifically to detect, track, and eliminate low-altitude threats, including drones. The system featured multi-spectrum radar coverage that could scan multiple frequency bands at once. Automatic threat classification algorithms sorted incoming objects into categories. Redundant sensor networks allowed the system to keep operating even when hostile forces tried to jam its signals. During normal operations, radar operators sat at their stations monitoring screens that displayed a three-dimensional picture of the airspace around the facility. The algorithms ran continuously in the background, flagging potential threats and distinguishing actual targets from birds, weather patterns, and background atmospheric noise. When the backdoor activated, it sent the Iranian modules into a recursive calculation error. The modules began reprocessing the same sensor data over and over in an endless loop. They couldn't move forward to the next calculation step because the corrupted firmware kept forcing them back to the beginning of the sequence. The compromised modules started feeding false data to the Kasuka-4's central processor. The system's core computer received information telling it that incoming drone signatures were actually atmospheric interference. Russian technicians saw their screens flicker, then display only background noise and weather patterns. FPV drones were crossing into the defense perimeter at 80 kilometers per hour, while the operators stared at displays showing nothing but static and false readings. Ukrainian cyber operations had infiltrated the facility's local defense network through a phishing campaign 2 months earlier. That malware sat dormant in the system until 2:47 a.m., when it activated simultaneously with the logic loop attack. It locked out manual backup systems that Russian technicians would normally use to override automated defenses and take manual control of the radar arrays. Russian defenses had been concentrated on high-altitude threats from the west, where intelligence suggested potential strikes from long-range systems. The eastern approaches received less attention. When the Kasuka-4 went dark, that eastern corridor became completely blind. Ukrainian drone swarms were already crossing the final approach to the factory floor. By 3:15 a.m., 17 FPV drones and 3 Flamingo stealth units had penetrated the factory perimeter. Russian air defense crews were still trying to manually reboot the Kasuka-4 system when the first explosions lit up the T-90M production line. The Ural-Vaganzavod facility at Nizhny Tagil sprawls across multiple workshops dedicated to assembling Russia's only domestically produced modern main battle tank. The complex is valued at roughly $1.5 billion and includes specialized stations where workers move massive components through different stages of production. The overhead crane system forms the backbone of this operation, lifting and positioning 50-ton T-90M hulls and turrets between assembly points. Without these cranes, workers can't physically move the tanks through the production sequence. The drones approached using terrain-following flight paths that kept them below 50 meters altitude. Natural ridges and the factory's own industrial structures provided cover as the swarm closed in on the target. Lead drones executed self-destruct sequences about 200 meters from the perimeter. The explosions created smoke screens and generated false radar signatures that pulled remaining functional defenses away from the main strike group moving in behind them. Russian crews manning Zu-23-2 anti-aircraft guns attempted manual tracking with optical sights. The twin-barrel systems have limited traverse speed. Operators shouted coordinates to each other while trying to acquire fast-moving targets without electronic assistance. The Flamingo stealth drones carried tandem charge warheads designed to punch through reinforced concrete and steel. Real-time satellite imagery guided these specialized units toward structural weak points in the workshop buildings. The primary targets included the overhead crane system that moves tank hulls, the Iranian optics assembly station where thermal imaging systems get installed, and the fire control integration workshop where electronic modules go into the tanks. FPV drones opened up with 30mm cannon fire to suppress ground crews scrambling to respond. The tandem charge warheads hit moments later. Multiple impacts severed the crane's support structure at critical load-bearing points. The primary overhead crane collapsed onto 3 partially assembled T-90M tanks sitting on the production line below. Secondary fires ignited stored materials and melted Iranian optics worth millions of dollars. Russia lost approximately 50% of its annual T-90M production capacity in that single strike. The workshop sat inoperable with reconstruction estimates ranging from 8 to 14 months. The Iranian components destroyed in the fires can't be sourced through the same supply channels anymore.